In this brief presentation, we would like to invite you to reflect on a question that is both timely and critical. Is the circular economy a revolutionary new model, or is it just a means to achieve something even more important, i.e., sustainability? This presentation is aimed at both students and educators. Our goal is to encourage you to integrate these concepts into your learning and teaching, and to approach them with a critical and informed mindset. Let us begin with the current industrial model, which is predominantly linear: take, make, use, dispose. This model has driven economic growth for decades, but it comes at a high cost: excessive resource extraction, massive waste generation, environmental degradation. Clearly, this is not sustainable in the long term. We need a new approach, one that reduces pressure on natural systems while maintaining economic and social well-being. The circular economy, or CE, is often presented as that alternative. It aims to close the loop, keeping materials in use for as long as possible, designing out waste, and regenerating natural systems. But here is the key point. The circular economy concept is not entirely new. It builds on earlier ideas, especially the field of industrial ecology, which has been around since the 1960s. Indeed, what is the conceptual framework of industrial ecology? Changing linear production processes, where raw materials are converted into products, byproducts, and wastes, into cyclic ones: used products, byproducts, and residues from a process become useful inputs to another process. Industrial ecology views industrial systems, or better, economic systems, as part of the biosphere, and aims to keep resource flows within economic systems for as long as possible. It draws inspiration from natural ecosystems, where waste from one organism becomes food for another. In the 1980s, researchers like Ayres and co-authors introduced the concept of industrial metabolism, analyzing material and energy flows through industrial systems, whilst Frosch and Gallopoulos developed the notion of industrial ecosystems, thus making a decisive contribution to the revival of the industrial ecology concept. Their paper, published in Scientific American, is considered by many the foundation of industrial ecology. One of the most famous examples of industrial ecosystems is the Kalundborg Eco-Industrial Park in Denmark, where organizations exchange waste and energy in a symbiotic network. Over time, industrial ecology has evolved to include a wide range of approaches and methods: life cycle assessment, material flow analysis, design for environment, eco-industrial parks, product service systems. These tools help us understand and redesign industrial systems to be more efficient, less polluting, and more sustainable. The circular economy builds on these foundations and takes up several of the concepts found in industrial ecology as well as in other fields. According to the Ellen MacArthur Foundation, CE is based on 3 principles: design out waste and pollution, keep products and materials in use, regenerate natural systems. It operates at multiple levels: micro, individual products and companies; meso, industrial networks and eco-parks; macro, national and global policies. Some scholars even propose a nano level, focusing on specific materials and components. But is circular always sustainable? Now we come to a crucial distinction. Circularity and sustainability are not the same thing. While circular practices can support sustainability, they don't guarantee it. Let me give you a few examples. Textile recycling programs often result in downcycling, turning high-quality fabrics into low-grade materials that can't be recycled again. E-waste recycling can involve hazardous chemicals and poor working conditions, especially in regions with weak regulations. Biofuels, if not managed carefully, can lead to deforestation and compete with food crops. These examples show that more circular does not always mean more sustainable, especially when we consider all three dimensions of sustainability: environmental, economic, and social. So, how do we know if a circular solution is truly sustainable? There are many circularity indicators. They measure things like resource efficiency, recycling rates, and material flows. But these don't always capture the real sustainability impact, especially on social aspects like labor conditions, equity, or long-term resilience. That's why we need tools like life cycle assessment, social LCA, life cycle costing. These tools are complex and data intensive, but they help us evaluate solutions case by case rather than assuming that circular is always better. What can educators and students do? As educators and students, you play a key role in shaping the future. Here are a few ways to integrate these ideas into your work. Include circular economy and industrial ecology in your curricula. Encourage interdisciplinary thinking, combine engineering, economics, design, and social sciences. Promote critical thinking. Ask not just, is this circular, but is this truly sustainable? Let's move beyond buzzwords and embrace a more nuanced, evidence-based approach. So to wrap up, the circular economy is a powerful concept, but it is not the end goal. Our true objective is sustainability, a balance between environmental health, economic prosperity, and social equity. Circular solutions can help us get there, but only if we evaluate them carefully and use them wisely. Thank you for your attention, and we hope this presentation inspires you to explore these topics further in your studies and teaching.